So quick thing, I'll be very honest. I was like, working on these questions, but I still feel very underprepared. So I'll need a lot of help from you all to, put in these questions. Whatever you think, just put it over there. I just have like one sheet of paper, and I'm gonna ask whatever comes to my mind. It's not gonna be like a very scripted fireside chat or anything like that. But getting started, Swaroop, let's get start right here. You did your PhD here at ASU, where you briefly did research under Professor Baral. Tell us like a little bit about yourself.
First of all, thank you very much for inviting me. It's always a pleasure to be here. Um, yeah, myself, I did my PhD here. Just was working with Gemini for some time in Seattle on the Institute for AI. Also with Microsoft Research and Google Brain. I joined Google Brain a few years back, a couple of years back. I was there then I transitioned to Google DeepMind, and then recently moved to Microsoft AI like 7 months back. Mostly worked on AI, especially LLMs like reasoning, instruction tuning, instruction following, like core language modeling stuff, how do you build these powerful language models. Like mostly did PhD mostly work on like how can these models follow instructions to math reasoning, those kind of stuff. Wrote some early papers in this area which later being used in many of these powerful language models. Then Google worked on Gemini. I'm part of this team which got like silver IMO last year. This year got the gold medal. And also like recently working on this Microsoft AI and building a foundation. Yeah, that's about me.
I see. Moving forward on that, like asking a little bit in depth. So those of you who don't know, sort of worked as like a software engineer at MathWorks, right? And you did your training in Boston, and then you were working in India for some time. What would you say like was a single, realization that made you switch from like a software engineering job to like a deep research program, like working at these top research AI labs?
So it's like what you want in life, like in the sense I feel like I was always fascinated by research and like understanding, the universe, how it works, like how basic things operate. Like in software engineering, you get a lot of pleasure in like building things, and like people use a lot of real world impact. But especially this AI, I was initially interested in physics. I like if you see my original research work started in there's a research institute in India. It's called Harrison Research Institute in Allahabad. That's a physics research institute, a theoretical physics institute. I was like enrolled in an engineering program, but I was interested in physics. I was interested in string theory, like 1 to 25 different theories. I have a theory of my own back then. Could never publish the theory, but that. So that time I was talking about like when MathWorks time, like I felt like okay, we write like a lot of papers and we do a lot of theory, but how does it really impact the real world? So that's why I was like, okay, should I focus on writing more papers and I just should move to industry, and that's why I went to like software engineering job. And, but then what happened is like when I came to know about I was working on this deep learning toolbox, neural network toolbox in MATLAB in MathWorks for a few years back. That time I got really interested because neural networks are sort of like a world model. It's like in physics you have like different models to explain different physical activity and processes, right? But the neural network is such a single concept, single architecture that can explain a range of phenomena, like starting from computer vision to speech to text to a lot of these things you can model, right? It's sort of like a mother of all the theories, right? So that's really fascinating to me. Like how does those work? And I had a lot of this unpublished idea from physics, which I want to publish it. Is like, and that's sort of like, and then actually, to be honest, like having a software engineering experience is very much essential these days. Because even if you have a great idea, you cannot execute it unless you have a good software engineering skill. So, and also like working in industry also gives you a good experience on like what kind of problems to work on, what kind of problems not work on. Because a lot of this research problems are like too theoretical or too academic and they don't have like real world impact. So that actually helped on later on in my PhD. When I look back, like the reason I worked on this instruction tuning idea is like pretty much because how can we make a model um, usable by everybody? But think about it like from the first principle, like machine learning, you train a model, you test it, right? But then do you think a user has enough time to train a model or test it? Like user wants answer instantaneously, right? They want to give an instruction and wants the answer immediately, right? But this aspect, right? Like it's not about building a new machine learning algorithm, which is important, but how can we make a machine learning algorithm that everybody can use, everybody can benefit, so that the application part comes into picture? That actually, I think those aspects came by working in industry, and like I said, any idea you have, you need a good software engineering skills to be able to really implement it, or like you need a bunch of people who can do it for you. So I think that is super important. But yeah, like in my case, like when I started working on this the toolbox, I got like sort of like my old dream of like trying to do in physics, like that got triggered, and I wanted to like continue doing that, and I thought like the best way to do it is to go to a PhD program, because in PhD you actually have a lot of freedom in what you want to do, right? I mean, so before that you are like a generalist, like okay, you can do like a lot of different stuff, you can write code, you can design, you can like solve puzzles, you can do all kinds of things, but PhD is like one chance you get where you can make your, like you are known for an area, like you can start an area, like you can start a new training paradigm or like a new algorithm, and people will know you for that for the rest of the life. Because everywhere else, like when you go to industry and other places, you have like other responsibilities, like you don't have much real time to like start something of your own, right? So that's like that you get like some time, I mean, to give it a go and see if you can really, and you don't regret later that I didn't give myself enough time to like do some like innovative stuff. So yeah, that's the idea.
So, just to brief it up, you mean like having core problem solving skills, right? Like software engineering skills help you a lot in your PhD program,
Yeah.
right? Coming on the same thing, because you switched from software engineering to AI, why AI? Like, what was that realization, or like what paper or what research you read? You were like, okay, I'm going all in on AI. Like, there's network systems, like a lot of other stuff, right? A lot of cool stuff. Why AI?
Because AI can potentially derive all these things what you have and rewrite those things from scratch. And like connecting to what I mentioned earlier, like you can have like these specialized systems for specialized applications. Like that's why we have different branches. But AI is something like very abstract, very raw, and you can adapt it to any application you want. That means there's a lot of potential. Like think of the model sort of like self-improving itself. In that means you can actually redefine the way how things have been done traditionally. I can give you a simple example. Right? So back in the early days of AI, right, people use these rule-based systems. It's like, or like people inspired by the linguistic, like how humans speak, they come up with grammar, or like all these. People try to impose human-defined inductive biases to teach a model how to do things, right? And then if you look at those papers back then, it's like if you go to New York or like those conferences back then, it's like all this work on how can you connect CNNs in this way, that way, or like all this, this pattern recognition system extract this feature, that feature, and inspired from different part of like how humans perceive different things, and that just died as deep learning evolved, because the way we see things may not be the best way to do things. Right? And AI gives a avenue for the model to define its own stack. Like the way we see things, we may have this vision of like, okay, we need this to really imagine, really visualize an image, but AI sort of changes the stack in terms of sort of like learning everything end to end.
Right.
So that means like AI is sort of a system that has the power to rewrite what we already know in different fields.
Right.
So, I mean, just like now whatever you study engineering, you study science, you do programming. Programming is a must, right? You do physics, you do math, you do everything in programming is a must, right? This is how AI is going to be. Whatever branch you study, whatever you want to do, AI is going to be there. AI is just going to help things. As
Just like accelerate.
yeah, accelerate different things, and actually maybe rewriting a lot of these things which you already know and already taking for granted. Those things might change. And in my case, like I saw, like I told you, I saw this power that just like string theory, AI is something that can connect different paradigms we have in understanding the universe, and that is like very powerful.
Right.
So yeah, that's pretty much why I switched.
I think that gives me like I think to everyone in the room probably that gives like a very different perspective. When you say like AI is still gonna be there, like it will still be there. It's just gonna like make our things easier or like accelerate them. And I completely agree with that. Coming on to your self-improving thing, I mean, I have a question which I'll ask later. It's like an in-depth question. Those of us over here who don't know, so Swaroop was responsible for the launch of Gemini Reasoning, which was launched in Google I/O 2024, right? And then there was also an article in the New York Times where Swaroop was featured. There was this thing that how AI can basically defeat humans in mathematics. AI was able to get better score than humans in like a mathematics Olympiad. So I'll ask those questions later, but I think Han has some questions for you.
I think I am. Thank you very much for sharing about yourself and also for the insights. So you shared like one of the myths in AI would be introducing the way that human approach things would be the best way to train a model, but we learned through deep learning that AI can figure out utility. It's an exploratory problem. So in research, there are so many different avenues, so many unexplored ideas out there, and research requires a lot of creativity, a lot of ingenuity, but also just practicality, like you say, industry skills. How do we make our research relevant to people, not too theoretical? So as you navigate research, and as you're talking to students here who might be interested in research and kind of like navigating what they want to do, what would be your recommendation for exploring ideas, finding creative avenues for each individual to shine, to kind of like showcase their interests, while also making meaningful contributions that are relevant to developments of the time?
Excellent question. See, the first thing is evolve. Like everybody has their ideas, but until you benchmark it and you evaluate it with the right set of benchmarks, you don't know where your ideas stand. Right. So the first thing is knowing how to evaluate your idea. So in computer science, it's sort of relatively easier because you can write a program or you can write a software and there are like different benchmarks, you can just run it. It's much easier than Einstein's theory, which took a long time to evaluate if it is true or not. But then having a fair evaluation, like suppose you come up with an idea of like, you need to ensure that your baselines also include the same amount of compute and same amount of data and all those kind of things. That means, which is like going to conferences, reading papers, or like, there must be some related work, irrespective of how new the idea is, that always exists some related work somewhere, right? So knowing those, like standing on the shoulder of giants, they say, like knowing just reproducing those results is the first step I would do. Keep my idea aside. I'll first make sure I understand the basics. I know the baselines. That means reading the papers, like talking to the researchers or like going to conference and just know the basic setup. And then I would like, the quicker you validate your idea, better it is. Instead of like talking to 10 people, just do it, just implement. Or if you want to make a group, please make a group, find people. There are like people you can pitch it, and you can find like people who are really interested in your ideas, or make a group and see if it really works. If it really works, please go ahead and publish it. You can publish a paper, or you can make a startup out of it. If you are, or you can make a patent, or you can do a lot of you can write a blog post, you can tweet about it, you can do a lot of different things. But I think the two things I must emphasize is making sure what are the related works. I actually say like this is like what I learned the hard way. back in the days, like during my high school, like I said, I was very interested in physics, and I developed a theory which I thought is like it's a new theory. Which I still think it's a new theory, but I was not aware of any related work because string theory is like too far away. It's like people who do like to understand string theory, you need to understand a lot of different things like quantum field theory, statistical physics, a lot of different things. Like I was just like in high school physics, right? So I spent a lot of time working on my theory, but had I known the baselines, I would have probably published it faster or like those kind of thing. And also like I said, those areas are like difficult to empirically justify, theoretical areas mostly, but like computer science is like much faster. You can iterate much faster. You can know it's okay to fail, but fail fast. So that is important. And then the third thing is about ideas, right? I mean, so the thing is, people say you need to read more to get more ideas, but I don't believe in that. I actually believe in the other way, because more and more you read, more and more you get biased. It's obvious, like if you read A and B, you get ideas of A plus B, A to B, like all these compositions, but that won't be new ideas, right? It's like, but you'll see like hundreds of papers. You can write those papers, you can still get those papers published. You can get a degree, or you can get some citations, but that won't be a breakthrough. That won't be something like really change the field. So that like reading is also need to be a bit careful in what you read. Often reading something which is like very different from your discipline, like say psychology or cognitive science, which is not directly impacting. Like if you're working on machine learning, if you read a lot of machine learning papers, maybe you get biased, but you read some other disciplines, maybe that will inspire you. So those kind of things is important. So yeah, these two things I will make sure to emphasize to make a real impact. And sorry, there's one last thing. This is the time to do startup. So if you have a good idea, just do a startup. I think this is, and most of the people are like undergrad, I assume. So you guys have like a lot of energy, and if you think something is really cool, just go for it.
So read 2 papers and do a startup?
If you are confident, yes. I mean, if you think something works, just do it.
Thank you very much for sharing about all your experiences. Those are also very valuable to us, and yes, we'll keep them in mind as we navigate the degree. And yes, startup is also very trendy lately. I think it was also mentioned kind of like your innovations and your contributions to the groundbreaking work that solve some of the IMO International Math Olympiad problems. I would love to hear more about that from you. So how did you come to that work? Did that work find you, or did you find the work? And how did you navigate it? What were the challenges? What were the success?
So, I was like mostly doing instruction tuning, instruction following, because those were like the basics. Once models start following instruction, then you can think about reasoning and all those things. And I also was interested in math, like how can models solve math questions. Like we wrote this paper called NumGlue that is like consists of all this math, physics, chemistry, and like common sense reasoning, like those kind of things. It's like pretty early, like probably 2020 or something like that. We published a paper. We also published another paper, Leela, which is like lots of different math challenges, starting from grade 1 all the way to like calculus and all these hard math problems. And also like I'm part of the organizing committee of this Math Hair workshop that happens in UIPS. We did it in 2022. Again, did it last year in 2024. So I've been involved in math for some time, like especially doing this math reasoning. And then regarding the specific thing you asked, like IMO, that event was happening, and I just came to know about it, and I sort of like wanted to see how it. Just give it a try to see how does that look like. Because I myself, have never worked on like IMO level problems. I mean those questions like is we can train a model to do it, but even understanding what the model is saying, if it's correct or not, it's like difficult, right? Because those like proofs and all those things. So, but we have like luckily we have a lot of this IMO gold medalists who worked with us, like basically pair up. That's why like finding the right collaborator is important. So those guys helped us in evaluating the proofs and guide us like if it is correct or not, and get a lot of insights from them. And we specialize in model training, like how do we train models to be really good at solving complex problems. Yeah, and so yeah, that's how things pan out. And also like since you asked about math, right? There are a lot of unsolved problems. Like people who are looking for new problems, right? Like a lot of unsolved problems. You just go to Terry Tao's website. It has a lot of unsolved problems you want to work on. I mean, if you can solve, you know, even if it will help up language models, that would be a great thing. So yeah, that field has still a lot of things to do.
Regarding what Han asked, the IMO thing, I had a follow-up question. So this was the same thing that was covered in the New York Times, the alpha proof, right? Where you guys were able to get the silver medal. And there's this thing with Gemini, like how were you, like LLMs, are known to hallucinate. What were like some of the biggest challenges? Because I think you all basically bridged Gemini's informal reasoning with like formal verification. What were like some of the biggest challenges? You don't have to get in deep depth, because we know like there's an NDA that we signed. But if you can solve that, it'd be nice.
Well, yeah, I can tell some generic stuff in a sense. Hallucination is always a problem. Hallucination is not solved yet, but you can control it. Specifically, you can control it in a constraint setting. Like when you give model a lot of freedom, especially in natural language domain, there's a lot of freedom. One can generate anything it wants, right? So the chance of hallucination is high. But in math space or like coding space, where it is structured language, right? Because the token space is small, right? The possible tokens are small, so so that's like one way to control it, because yeah, like you said, that is, and then you can also do different kinds of, depending on what evals you care about, and depending on how do you interpret your system, you can do some kind of specialized trainings to control models' behavior. Again, so the short answer is like hallucination is not solved yet, but you can control it in different ways, and there are multiple ways to do it.
Is more context a way to...
You want to take the mic?
Oh, definitely.
So that everyone can listen to
Yeah.
that.
Do you think more context is a way to curb hallucination? More like increasing the context window, does that help?
Context monitoring?
Yeah, like having more context when you're, or like what else? Like what else can I do? Like in order to, and if you could tell me mathematically what exactly is hallucination?
Yeah. So, see, like how do you, let me take a step back. Like how do you, suppose somebody is like hallucinating, what do people do to sort of like fix hallucination? Is like, people often ask the question in different ways and see if the answers match or not. If the answer do not match, probably the person is hallucinating or person is lying, because if you tweak the question slightly, or if you tweak the suggestion slightly, now how do you tweak the question? You can paraphrase the question, you can add different context, like what you mentioned.
Yeah.
You can change the parameters, you can change the temperature, you can change different settings, and you see the answer is changing. And then you see if it is consistent or not across different answers, if those align with each other or not. Like that is one way from the data side you can fix it, right? But of course there are like sort of a lot of modeling things, the way we model these probabilistic systems. There is always hallucination. Even if you ask like a very deterministic questions, there is still 1% probability of like some answer which doesn't make sense, right?
Yeah.
It's always there, right? So there is something fundamental. So I mean, I'm saying what I mentioned is you can control hallucination either by controlled decoding or by changing context, paraphrasing question, checking consistency.
Yeah.
But there is something fundamental.
Is it because of learned overfitting or?
It's not overfitting. It's just what you want. See, the thing is, think about it this way. Hallucination is a feature. It's not a bug. Because we want, see, why do we want machine learning models? To be able to imagine to write a story, to write a poem, or like we have programs for deterministic systems, right? For doing things which we want, right? Exactly how it operates, like mechanical system, the software systems. We have there those things, right? We want some kind of hallucination.
Yeah.
That we want to imagine a video, want to generate an image,
That
right?
is creativity. Yeah.
So creativity, right? So we want, and even in like say math domain, right? Like we want to be creative in coming up with a new proof or a new idea, prove a new conjecture, coming up with a new lemma and those kind of things. So we want some kind of novel aspect, right?
Yeah.
That's a feature. But that feature is a double-edged sword because that also becomes that you have to handle the hallucination when it is.
So the temperature is a double-edged sword then.
Just one of them.
Okay,
There are like
one of them.
yeah.
What are some other features that?
Everything we do, the probabilistic model itself, when you talk about a probabilistic system, is designed to basically in the probabilistic system you are
Predicting the world.
Yeah, so it designed that it can never give 100% to one word, right? There will be some probability of some other word. That means you are teaching the model to hallucinate.
Yeah.
It's never perfect.
When you're changing these parameters, you are essentially messing with what word will be predicted.
Yeah.
Okay.
I think that's a very good time to open the floor for questions. You guys can scan this QR or type this in your browser if you want to submit a question. But if you also want to ask a question, can I get like a quick raise of hands if someone wants to ask a question? Other than Oscar. Yeah.
How do you detect false with confident citations by Gemini?
We'll give you the mic.
How do you detect false with confident citations by Gemini?
Well, I cannot answer. I don't know about Gemini, but I can answer in general if you're asking a research question, right? I'm not a product guy. I should ask like people working product, like if there's a feature to do that. So the false and confident citation is again the same thing which I already answered here. Is like if you ask the same model to give the citation and give the question and see if it is the same answer. And then if it doesn't, that means there's something wrong, right? Like you can cross question. You can like first you give the question and you generate the answer in the citation. Now you remove the answer, give the question and citation, and see if you get the same answer. And then you can also ask to expand the citation and write a paragraph in it, then remove the citation and give the question the paragraph and to see if it was the same answer. So you can do all this kind of cross verification. Or you can also do like this retrieval. You can actually have a retrieval setup where you use that URL to get information from the web and then pass that information, put it in context with the model, and you see if the information in that paragraph matches the answers. You can do this kind of cross verification. This field is actually, if you're interested, this field is called attributions. This is called attributed language modeling. Like when you attribute your answer to a specific source. There are like eval metrics and a lot of recent papers on that.
So this attribute is RAG component here, right? Or
One of them.
Okay. What are some other components?
Okay. Sorry, we'll come back to you.
Okay.
Don't worry. Yeah, we'll
It's
do
a
like
follow-up
after
on that
Don't
question.
worry. Yeah, don't worry. I know you're very curious, I think so many of us were here, like very curious to ask Swaroop questions, but we'll get time later.
Yes.
But we are running on a clock, don't worry. Do you have a question?
Yeah, I have.
Han. Yeah. If you can speak loudly, that works too.
Why are LLMs bad at math? Like adding numbers, I could ask it to like add 0.0056 or whatever. And
It's
is
all
it because
good.
the lack of that kind of training data in the training process, or is it just by the nature of how they work? And then, yeah, that's my first question.
There's a lot of papers on that. It's like basically there are different components. One of the key components is tokenization. The way we tokenize text, it's like divided into small chunks, and that sort of benefits text, but that doesn't make sense for numbers, right? Because that addition you can do because each position is a specific value attached, right?
Yeah.
But you remove that information gets lost. Someone wants to learn. There are like a lot of papers on if you train a specialized model that should do those things, that you can do it really easily. It's an easy task, but tokenization is one of the problems.
So is it the limitation of the, sorry for a follow-up, but is it a limitation of the current architecture that you cannot pass?
So the thing is, the current architecture is like, it's like what use case you are catering to. We are more interested in generative use case, like the text-based use case. because that is what a lot of application covers. We don't, I mean, because those things calculator can do, a Python program can easily do. So that's not what the main use case is. But you can do that easily, and there are other ways, like you can add in chain of thought, and like if you look at the current model, that's pretty good at it, because it sort of like reconstruct this position information by generating chain of thought and thinking more and learning that. But that's the original problem. It's been there for a few years now.
Makes sense.
So question I had was like before the entire GPT-2, GPT 2.5 phenomena that happened, essentially, that the usual trend with the machine learning on the AI space was that we would have like really hyper-specific small models, where we were moving towards more of an ensemble kind of a scenario where we had smaller models which were maybe not that well trained on like many different things, but they were hyper-specific, well trained on a very particular task, and you would have this array of them working on to solve a bigger problem. But with the advent of GPT, I think the general direction that we see in research right now is larger and larger context windows and enormous amounts of data just to train a model that is sort of a generalist, but still fails in a lot of basic reasoning tasks essentially. What is your perspective? Like, do you see the trend moving back towards a scene where we have smaller model, like maybe a 300 million model, which is trained on a very specific kind of a task, and like we have a sort of a dashboard where whatever our query is based on the kind of query we've done, we basically get those models instead of having a generalist like a Gemini 5 or like a Gemini 2 Flash model, which is extremely good at answering general questions, but still very poor in answering like very hyper-specific questions on a particular topic.
Yeah, you know what? A lot of these industries, they don't want to, send their data to APIs because of all this privacy and other things. So they have their own special models in-house. And of course, because of this compute constraint and all those things, they often have small models. So that, having said that, but there is a true power in transfer learning that happens, and a lot of this emerging phenomena, like that happens only at scale. But then the question is that, do you need those use cases? Many of these times, like, especially if you think about your industry, you have a specific use case, you don't care about like, AGI or like all these use cases in the world, you only care about a narrow domain. Often that makes sense. That means like you just train your model on those specific use cases, and that's also cost effective and also secure, there is data space with you. So it's actually a case by case basis. I would not say there is a single answer to that. But if you ask people like me, we believe in AGI. That's like a single model that can do things, and we believe in scaling. We believe that there is this collective intelligence of humans in the internet, and if you can get that information and absorb it, there are like different ways to extract those information. That's why this different architecture has been made. So we continue to believe that as we scale and come up with new and smart ways to extract information from the internet, from the collective intelligence of so many smart people on this earth, we should be able to make the model stronger and stronger.
We have some questions over here.
Yeah.
I'll just give it to you, the ones that you want to take, a bunch of questions.
How to get into DeepMind if you have to start now? I guess there is an career portal, you can submit your resume. I mean, okay, on a serious note, I think if you want to like get into any top research team or like any top AI team which are like working on state-of-the-art language models, I think write some high impact paper. That is like a must. In the sense like, what is a high impact paper? Like a paper which gives rise to so many other papers, which starts in area of its own, right? I mean, not all paper can be a transformer paper, right? You can start off like thinking of doing a new training algorithm or a new method or something like that. I mean, if a lot of people follow that work, I think those definitely makes things easier, because then you'll have options. Like people reach out to you to work with you, instead of the other way around. So that's what I suggest. Should I take more questions from here or should I?
Does someone, let's just do like one last raise of hand.
Yeah, question you asked.
Mo?
My question is really
Uh,
you having worked on DeepMind and Jeffrey.
Can you speak a little bit louder so that everyone can hear it? Use the mic.
Now can you hear me?
Yeah.
Okay. So this is my broad spectrum because you have already worked on the DeepMind and Jeffrey Hinton was almost he was the godfather of it. So and you also talked about AGI. Do you think AGI still AGI would be really strong and our intelligence it has already I believe LLMs and AI has already superseded us and in the intelligence and the technology would never stop. So what would we do kind of stuff?
See, it also depends on like what's the definition of AGI. If you talk about like AGI being model being as good as average human, then we're already there, right? Like a lot of these different things, like starting from writing email to writing code to generating image, generating video, model is pretty good, right? The way to see things is it's sort of a revolution that is happening, which has always happened in the history. If there's a mechanical world where like a lot of people are doing this, like a lot of mechanical work and shifted to the electric domain, and then computer science people doing the way we work in daily life has changed, right? And to write programs instead of doing a lot of work manually, right? The computer science has taken this sort of like the role of job profile has changed, and the similar thing is going to happen with AI. I don't think it's anything to worry about. You know, it's sort of like augmenting, but we need to. It's like we need a different set of skill set to be able to correctly use AI or like keep contributing to developing better and better AI. That's what I said. Just like a few years back, somebody introduced programming in every domain, every discipline you study. Everything you study, be it engineering, be it science, you have to do programming. Similarly, I think AI is going to be added like that. Like whatever you study, whatever you work on, whatever domain, AI is going to be added to that. And then the challenge is like how to use AI, how to build AI. I think the problem statement is going to change, but I don't think an AI can ever replace a human. Yeah, I don't think that.
Industrialization was a very different threat. It used to target a different sector. AI has targeted every sector, and AI will almost. What skill set would you recommend, or would you see as us or someone who wants to build some skill set who can augment the AI and still be very relevant in the future?
Thing is like people say humans don't need to code because AI can write the code. I actually think the other way around. Humans need to code better because AI can write so much code now. It can write like 10K lines in like few minutes. But it's very difficult to understand what it is saying. It's like just writes like blows the code base, right? So the debugging skills becomes more important because it's like it creates a small bug somewhere. It is just going to mess up everything. And then understanding like architecture, understanding systems, understanding architecture. Because remember, even though LLM has been trained on all this internet and all those things, the attention structure is still not dense. There is model keeps perverting thing, and attention span is still short. The experience you have regarding the system, like computer systems, right, or like finding a security issue or all those kind of things, it's not there in the model. Maybe that will require a different kind of research, but I think human experience in like jumping things, like think of it like transformation next token prediction, right? So it can it has this limitation of how many tokens it can look into, how many tokens it can generate or something. So because of that limitation in context span, that human knowledge in jumping things, like you can actually quickly remember from your past experience that okay, maybe the problem is in this file, which the model is difficult to. So debugging skills, understanding, and that's important. And also like I would say like keeping it staying more open-minded and like learning from different disciplines, how we model the world, like different learning from maybe psychology or computer science, those kind of things, and try to inject it to come up with a new kind of algorithm or like new kind of learning method in AI. I think those are the two skill sets. Keep this in mind.
Just the last question. Do you think the safety standards for the AI is lagging behind the technological advancement in the AI?
We are making good progress on that. Lately, there has been like a lot of effort in ensuring a lot of like policies getting made, and all this like top leaders are talking about it. There will councils being made. So yeah, so this is like a new technology. It's not there before. So I mean, similar to any other technology. So it's like a first of its kind. So we are like working towards that, and luckily we have made progress very recently.
Bless you.
I think Mo had a question for you. So I'm going to be starting a PhD next year, and because of the field is torn between training time compute and test time compute, in your opinion, what should I focus on? Because it seems like academic labs can only have the compute for inference time, but it seems like OpenAI and Gemini already maybe have saturated that. So it's like you can't, academic labs can't do RL. So it seems like, I don't know.
No, that's not true at all. Actually, partly true, partly not. In a sense, like think about these things. Just nobody's thinking diffusion models, for example, right? Or like some other kind of architecture, totally different kind of architecture, like this Mamba and all this, linear RNNs and all kinds of architectures. We don't have time in industry. Industry is like a lot of time is more in the exploitation mode, right? There's not much time to explore. You get a lot of time to explore. That is the part of the question. So a lot of these things you can do it in PhD, probably you cannot do it in job or elsewhere because you need to prove things to do it, and you might not have enough time to prove it, right? So that's part one. Part two, I agree. You need at least a minimum amount of compute, but luckily these days, most of these labs have compute, and otherwise you get associated with a research institute, like be it like any industry or a non-profit research institute, they have compute, so you can get attached to that. In my case, I got a lot of help from RNAi because I got a lot of compute resources from there, and that actually helped me in conducting experiments. So you need both, but there is pros and cons in both sides.
Got it. So it's like a balance between compute and just trying creative architectures.
Yeah. And I would actually, like, if you ask me, I would actually, if I were to do PhD again, I'd like to work on something like diffusion, something which is like very different, or like maybe some other kind of crazy architecture stuff, which may not really work, but I won't regret later that I didn't give it a try, because this is the time I can do those things. Probably I cannot do those things later.
But it would still be one model.
I mean, that's what I believe in, but you can prove me wrong. You can come up with multiple models that works. Right?
Orchestration.
Yeah, maybe. I don't know. Like, this is like, I just said my belief. Like, maybe, I'm wrong. It's possible.
You can diffusion.
Thank you.
Yeah.
Let's do some questions from the ones that are submitted online.
Yeah.
2 of your favorite questions from there.
Oh, yeah.
And then we have some other questions which were like,
Yeah, so this is like it. Is more compute the path to AGI, or are we likely missing something? Yeah, I mean, yeah, people like me believe compute, but it's not just compute, right? It's sort of like, how do you extract the indexing bias from the data you have? Like, think about it, right? Like, you have a same textbook that a lot of people study from, and somebody becomes like a great scientist and creating like new science and those kind of stuff, but somebody just barely passed the exam. So like the data is the same, but and compute is probably also the same. Both of them go to the same school, spend the same number of hours, but the reward they extract or the information they extract are different, right? Depending on how your architecture is designed, how you get generated inductive bias. So compute is one, but it's pure compute. I don't believe in that. I believe in like smarter ways of extracting information from the web. That means like coming up with new training algorithms and new architecture and those kind of stuff. What steps would you recommend for someone interested in pursuing AI ML engineering? This is like the question which I probably answered the most in my life. But yeah, one more time. How to pursue AI? Yeah. Yeah. So I once read about like this 5 courses, like this open source courses in Stanford, CS224, CS231, There are like 5 these courses that sort of like gives the basics of what you need to know about AML, like how basic model works, or like how AWS and like basic things works. And I think I would do those courses. Like I'm just saying, like for anywhere, like if you want to start from scratch, I would do those courses, and that has some prerequisites, like you do linear algebra and like those kind of stuff. I would do that, and then I'll do some projects. But likely I'll try to implement a research paper. I just try to reproduce the results and just know how to implement stuff, get the baselines correct and those kind of things. And then probably I'll go and talk to a professor or like some student, PhD student, try to get into a research project. That's try to build things, try to learn how to scale up things, manage full stack and a lot of this engineering skills. And I think, and then from there it's after that, what's your strength? You like to do more like a research, then you can become a research scientist, or like in a research role, or if you like more like product, then you can be involved in a more like a startup, get into more engineering roles. That's what I would follow.
I have a better idea. So we have a lot of questions. What we can do is I can send those to you, and later maybe we can share them on our Discord server or Instagram profile. Like answer them one by one in Swaroop's own language, and a lot of you guys' questions will be answered. But we do have a couple more minutes if someone has a question from the crowd. Yeah.
Hello, can you hear me? Hi, Swaroop. Many people here that have been involved in some form of research have been like recently noticing a trend where all of research is just making API calls, making API calls to Gemini, making API calls to ChatGPT, AO. So my question is, do you think this is the direction and future of AI research as a whole? And if I want to do something in addition to just like making API calls, like what would be the first step?
See, first of all, I would not characterize making API calls as a bad thing.
No.
Because see, like you don't have probably like not everybody has a lot of compute to develop foundation models from scratch. But then having these foundation models, how do we really unlock the power of those models? That's actually an unsolved problem. A lot of these things we don't know how these models are capable of, like how we can align those models together to do different tasks. We wrote this paper back in the days called the question decomposition unit. All you need is like, if you know the right way to use these language models, if you know their strength and weakness, you can get a lot of things done. So that's actually an interesting area to work on. Like think of this, right? Like the programming you're doing, right? In the programming space, like you can also think of like you're doing an API call because you're not inventing a new syntax. The syntax are already there. You just keep calling the syntax again and again, right? But within that, it's very powerful to build powerful programs, right? The same thing is here. You're not touching the LLM API, but you're calling them in different ways, trying to write a natural language program and trying to do different things. So that is one. I think it's a really important one to work on. But what other things? So yeah, of course, like I said, you need to think about like more from the first principle, like the way the transformer is designed, the way we train, the way we do RL. Is it the best way to do things, or is there are some limitations? Of course, there are a lot of limitations. Like humans probably don't generate token by token. Humans probably think all the tokens at once, right? Or humans probably backtrack. Those things models cannot do, right? And then humans probably don't backpropagate. Like there are a lot of these kind of questions from first principle which we know, but we don't know how to solve it, right? So I would work on one of these problems in a constraint setting. Of course, like I will not go for too big language models, but try to solve one of these research problems.
Thank you.
There is. So take more questions.
Of course. It's already yours. You're the guest.
Can I ask one question? Just one.
At the lunch break, at the
Small.
let's just do one for that. It's fine.
Yeah, but if you want to answer.
Yeah, please, anyway.
So my question is, what kind of advice do you have for someone who's early in his career, and what kind of key qualifications that contribute to your success in your career?
So I think the first thing is, which is a must, like having a good software engineering skill. Because otherwise you have a lot of ideas, but then you just have ideas, you don't know how to implement it. So having a strong engineer is sort of a bare minimum requirement. Anywhere you go, I think that's a must. The second thing is, like I said, more and more you read, more and more you, as you become, people say like, as you become senior, you get dumber. In the sense like, you get like, you assume things, right? You take things for granted, right? And like I said, like if you read more papers, you're going to get ideas for the composition of those papers, right? So, having spending some time early on in the career to work on really ambitious and creative stuff. That means like taking courses from other disciplines, reading other books and try to get ideas, and from there or like find some ambitious ideas is always good, because that's how you set your tone, right? Like if your first project itself, is very ambitious, it's okay to fail, but then that is going to decide how you're going to progress further. Your like the thinking space increases, right? Yeah. But if you start with something like basically something incremental, I think it's probably going to be difficult if you continue doing that to come up with a really because you're going to bias as you actually study more and more. So yeah, software engineering is a must, and the second thing is trying to be doing some kind of creative stuff and getting inspiration from other disciplines. I would do those two things.
Thank you.
I can take only one more question from here.
Yeah, sure, and then maybe Utkarsh too. He's just looking at me over there. I don't want him to do bad omens for me going back home. Mom
You know that's not going to happen. Come on.
All good. You
Yeah.
can.
So there are a couple of questions on the instruction tuning work. So okay, I can take this one. Professor Chitta Baral mentioned you and few others in your team were among the first groups to work and propose instruction tuning. How did that early work shape what actually shipped? Yeah, so again, that's when we are, this is like what, 2020 or something like that, when we were thinking about those ideas. That actually sounded very ambitious that time. A lot of people doubted that it looks more like a sci-fi than it actually worked, because that's against the basic premise of machine learning. Machine learning is like, you train a model and you test it, right? Instruction tuning means you don't have to train. You just train it once and get run from instruction, right? But yeah, I mean, we gave it a go, and then luckily the results were positive, and the results are actually really good. When you look at the results, the first experiment, like normally most of the research projects you work on, the first time it never works, right? The first time it always fails, like you get like, oh, this doesn't work, I have to tweak this as a parameter, I have to do some changes and all. But that's one project where the first real implementation, the results were like really, really good, like crazy good. Like the numbers were like double of the baseline. That was like surprising. Like first time I was like, okay, did it do any mistake? Is there any leak or something? Is this something? But then that is what like the results were so good. How it actually shipped, that is like 2021 we published a paper, Natural Instruction. Then I think Google has this paper plan, which came later that year. Then if you remember Instruct GPT, which is actually a precursor of Chat GPT, that came sometime in 2021, end of 2021 probably. And then that became a new area. A lot of people started working on that. And then actually became popular, of course. Chat GPT actually sort of like make it like a lot of people worked on it, and so yeah, eventually it shipped in the form of chatbots to answer the question. But initially it was like just a research project to see how things go.
Let's do one last question from Utkarsh.
Top 3 up and coming architectures to look into. Top 3 up and coming architectures to look into. Not the standard, but that have potential in your opinion.
Okay.
Yeah.
I'm very inspired by this linear arguments. And then also I'm very inspired by the diffusion models, specifically because like when I'm talking to you, right, I'm probably saying one word at a time, but I'm not really thinking for every word, right? I have thought about what I want to answer,
Yeah.
but I'm really disconnecting words to express what I want, right? What I want to say. That means like if possible, I can generate everything at once, right? So I think that is probably missing in transformers. So diffusion is also in my list. There are also like this physics inspired models. I don't know if you have seen those papers. There are like all these biology inspired networks, like people like Jeff Hinton always keep saying humans don't do backprop, so they're like, and so it's not biologically plausible to do backprop for humans. So I like a lot of these biologically inspired networks. I also want to see some of those work. These are the top three. But yeah, I want you to come with something different.
Nature will be inspiring them.
Yeah. The thing is with nature, right? Like we always get inspiration from nature, but there are a lot of this constraint which exists in computer space which don't exist in nature. For example, right? There is this gradient flow problem. I mean, humans can have unlimited gradient flow because, like, okay, you did a mistake, you learn higher from that. But if you do it in the model space, it's just the gradient overflows, and then it just there's a lot of memory issue, and then because of this how the mixture of experts work, the routing mechanism goes wrong. You have limited memory, and there are like a lot of constraints which exist in the computer space. Machine space, which is not there in nature. So of course you get inspiration from nature, but a lot of these things are not possible. Similarly, the vice versa. A lot of these things, like probably human cannot like operate like for days without like stopping, but machines can operate, right? So there are a lot of strength and weakness of machines to consider. So lately I have been being more practical, even though a lot of these things are not feasible in nature, but we just go with it as empirically it goes.
What about complex adaptive systems?
So that's one of the natural systems, right? Like that's how a lot of these biologically inspired networks, that's how it's designed. But to the scale, probably not. I think the one thing you want to see is like a lot of these kind of architectures have a good proof of concept, like they've like generated good results, became papers and all those things. But when it comes to scaling is the most important question in deep learning, right? If it really scales, sure or not. If it doesn't scale, sorry. I mean, it may be a cool architecture, but you can't do anything about it.
So it has to scale because of just the way the industry is done.
You're right, and also part of the thing is also because the way computer is designed. So the way, also understand that architecture, like machine learning research and compute hardware go hand in hand. Like transform became powerful, and then later on, because you can parallelize a lot of things, and later on the GPUs and all this compute hardware that's designed were optimized for transformers, right?
Yeah.
I mean, you can argue that like somebody maybe make this biological inspired networks works, and then somebody also supports them by creating like these new compute resources that actually helps those algorithms optimize. But it's a long way to go, right?
If the compute is absent, then it's obsolete in the moment.
Right.
Come up later.
That's why LSTM's gone, right? Because they could not utilize the compute. So.
Yeah.
Alright guys, we're almost out of time, but I have a quick idea. We should get a picture together. Since we're number one in innovation, I don't know if you'll be able to fit over here. What we can do is, Swaroop and maybe Ashwin and Alvin and Sachin, if you all want to stand here, and we can take like a picture from the side so that everyone's covered in the frame. And help me, thanks Swaroop for coming all the way from Bay Area just for this event. Let's get a picture together and then we're gonna get the tacos.
I am stopping now because of the food get mad.
Also, if you guys have any questions, you guys can still talk to Swaroop. The questions that you shared on the forums, what we're gonna do of those is like, we'll make like a Discord announcement and I'll ask Swaroop to, share all those answers. Please get seated, guys. Like, don't get up just yet. Let's take like a quick picture first. Can I get my phone back?